objective, which is electronic configuration. And just as I keep on saying in science, it's not all about memorizing. So what I can say is that this word is coming from the word electron. And then when we say configuration, it means to put in order. When we say to configure a machine, it means to put in order. So electron or electronic configuration means arrangement of electrons in order. The arrangement of electrons in order, of course, in an element. So now the new thing that I'm introducing is that every element has an electron, and these electrons, we need to arrange them in order. So what we need to look at is, I just decided to put the first 6 here. How is hydrogen, He is helium, lifted is lithium, Benjamin is beryllium, Born is boron, and then Can is carbon. Now, this is the reason why I told you that you need to know the first 20 elements, because it will help you here. Now, I know that hydrogen is element number 1. What it means is that if I want to look at number of electrons, I can easily conclude that since hydrogen is element number 1, it has 1 electron. Helium is element number 2, it has 2 electrons. Lithium is element number 3, it has 3 electrons. Beryllium is element number 4, it has 4 electrons. Boron is element number 5, it has 5 electrons. Carbon is element number 6, it has 6 electrons. You need the number of electrons that these elements have to be able to deduce or write its electron configuration, or to put the electrons in order. Now, there is a rule for writing the electron configuration. We normally say the shells. I think you remember when we talked about, we drew the structure of the atom. We had a nucleus having protons and neutrons. So that's what we are going to use here. What we are going to do is that the first shell, anytime you have an atom, the first shell takes 2 electrons, the second shell takes 8, the third shell. Now at this level, secondary, science for secondary, the third shell takes 8. In fact, any other shell aside the first shell takes 8. So when we look at hydrogen, it has 1 electron. It doesn't even have up to 2. So when we want to write its electron configuration, we easily say that it is 1. We just write 1. When we take helium, it's element number 2, which confirms that it has 2 electrons. So it is 2, because based on the rule, the first shell takes 2. When we come to lithium, lithium is element number 3, and it confirms that it has 3 electrons, and the rule says that the first shell should take 2. So 2, and when you take 2 from 3, it will be left with 1. So 2, 1. That will be the electron configuration for lithium. When it comes to beryllium, the same procedure is element number 4. So the first shell takes 2 electrons, the second shell will take 2. When it comes to boron, 2. The second shell will take 3. When it comes to carbon, the first shell takes 2. Then the second shell takes 4. Now, can we try this? Calcium. Calcium. In fact, those of you that know the position of calcium in the periodic table, calcium is element number 20. So it confirms that calcium has 20 electrons. That is why I want you to be able to recite the number, at least the first 20 elements. So you realize that calcium has 20 elements. Now the first shell for calcium, 2. The second shell, 8. Because it has 20, so I'll get the first shell 2, I'll be left with 18. Second shell, 8. Third shell, 8. That will be 18. And when I subtract 18 from 20, I'll be left with 2. So 2. So I'll say that the electron configuration for calcium is 2, 8, 8, 2. I can ask you chlorine. 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 If I want you to write the electron configuration of chlorine, if I want you to write the electron configuration of oxygen, if I want you to write the electron configuration of aluminium, chlorine is element number 17. So it has 17 electrons. Now when we want to write the electron configuration, the first shell is 2 to be left with 15. So the second shell can have its maximum of 8. That will be 10. And then we'll be left with 7. So the electron configuration for chlorine is 287. Now we come to oxygen. Oxygen is element number 8. It's element number 8. So it confirms that it has 8 electrons. Now when it comes to the electron configuration, the first shell takes 2. And when you take 2 from 8, you'll be left with 6. So that is the electron configuration for oxygen, 2, 6. Then we look at aluminium. Aluminium is 13, element number 13. So the first shell takes 2 electrons. And then the second shell takes a maximum of 8. That will be 10. So when we take 10 from the 13, we are left with 3. Good. I'm sure with this, if you know the position of the elements in the periodic table, you will be able to deduce or write the electron configuration. From experience, once again, if you've been watching our videos, you should be able to do this. I'm being so kind to put the atomic number here, which is the number of electrons that the element has, and I'll put 2 here. Now I need you to take a closer look at this. I remember telling you in the previous video that anytime we write an element and we bring a charge, negative means it has gained, positive means it has lost. Now, when we look at oxygen, it has, or its 8th position in the periodic table is the 8th position, which means oxygen has 8 electrons. But negative 2 means it gained 2. So this oxygen that we are talking about has 10 electrons. So if I ask you to give me the electron configuration of this, you don't write the electron configuration based on this 8, but you write it based on the 10. So it becomes 2, 8. We can take another example. Chlorine. Okay. Let me use a positive. Aluminium. 3+. Don't forget that in science, when you see positive, it means lost. So I know aluminium is element number 13, which means it has 13 electrons. But the presence of the plus 3 tells me that it lost, it gave out 3 electrons. So if I was having 13 and I lose 3, I'll be left with 10. So when you are writing the electron configuration for Al3 plus, you don't write it based on the 13 electrons, but you write it based on 10. So it becomes 2, 8. We can look at calcium, 2 plus. Calcium is element number 20. So when I ask you to write the electron configuration, it has 20 electrons, but be mindful of the charge. Plus 2 means loss of electrons. So if you have 20 electrons and you lose 2, you'll be left with 18. Now, when you want to write the electron configuration, first shell takes 2, second 8, third 8. So you see that the moment you bring the charges, the electron configurations, they change. And that is one thing that I want you to observe. I'll still plead with you to subscribe. Go to Fin Educational Center, share, and then subscribe our video.